What's going on, everybody? Back again with another differences video for the 7.5. We just did hydraulics, and now we're going to talk about fuel. Hydraulics didn't take too long. It was only about 20 minutes, so hopefully fuel will be about the same, if not a little bit less, because there's really not a lot of differences when it comes to the fuel system of a 7.5. The main things we're going to see that are differences are going to probably be more capacity related and some other minor things. Nothing really changes when it comes to actually operating the airplane. All right. So when we get into this, I want you to remember that the 7.5 is a narrow body and the 7.6 is a wide body. So when we start talking about the differences in capacity, that's why. Okay, because the 7.6 is a much larger aircraft. So if we start by looking at our capacities for what our different tanks can have. Now, granted, these numbers are, it's a generic 7.5. Like, I just picked one and pulled it out. There are some different numbers that'll come along with the 7.5, but really it's not going to be any much different, maybe 2,000 or 3,000 pounds different, which I know sounds like a lot, but it's really not when you're talking about an airplane that, takes off at 250 plus thousand pounds at a time. But looking here, we got left main, right main, center. So we have three main tanks that hold our fuel. And then you can see that the total there is somewhere around 75,549 pounds. Now, again, it's going to vary depending on the aircraft. Let's think about the 7.6 capacity, though. So this is where one of the major differences comes in. The 7.6 can carry up to the 300 version anyway, can carry up to about 160,000 pounds of fuel. The 200 a little bit less than that. The 400, I don't know. I don't know anything about the 400. So if you have information on 7.6 400s and you can send it to me, I'd greatly appreciate it. I'd love to learn a little bit more about the 400 side. But the 300 is what I know. It's what I teach all the time, and it is the most prevalent 7.6 that's out there right now as far as numbers are concerned, with cargo airlines using quite a bit of them right now. So 7.6 300s hold 160,000 pounds of fuel. Now, how those numbers break down are going to be a lot different than the 7.5, but essentially the center tank, again, is going to carry the bulk of it, and it's going to be about 80,000 pounds of fuel. Now, we all know that we talk about pounds and not gallons, right? So we're not talking about a ridiculous amount of gallons. We're talking about pounds. So about 6.7 pounds per gallon. So you divide, 75 by 6. Here, I'll just do it just because I'm curious now, and I've done this to myself. So 75,000 pounds of fuel divided by 6.7, which is the rough density of fuel, 11,194 gallons. It's still a hell of a lot of gallons, right? So now that we're looking at that, let's look at the actual setup for the aircraft. In the airplane, you got two wing tanks, the left main, the right main. Then you got one that's called the center tank, which is also, it's a body tank. So it goes across the fuselage on the bottom side. It's in between your forward and your aft cargo compartments on the bottom side of the airplane. So that's where your center tank is. It's going to run across there. Now it does kind of go into the wings a little bit, but for the most part, it's all across the body. So the setup is almost identical to what it is. Well, it is identical to what is in the 7.6 300. The only difference is the size of the tanks. Now you'll see that we have slosh tanks on here. So out here and over here, we've got some slosh tanks, and that basically, the fuel will slosh out into them during turns and maneuvers and that kind of thing. And then when the airplane goes back to straight and level, that fuel will then gravity feed back into the center tank, just like in the 7.6. Now, if you've been a part of the aviation community for any amount of time, and you've been on the internet for any amount of time, I'm sure you've probably seen some meme that looks like this, where it's comparing the amount of water in this tank, comparing it to how much fuel a 7.4 can handle, and asks, well, where does it go on the airplane? And I know that the people that post these, they're doing it for one of two reasons: either rage bait for somebody like me, or they're doing it because they just don't understand airplanes and they don't research it. And this kind of goes to show that no matter how much information is on the internet, some people just refuse to look at it. But according to a company, Steel Core Tank, they produce these types of tanks, and a 60,000 gallon tank is going to be about 27.1 feet in diameter and 14.2 feet high. Now, what does that mean? That means that we have about 5 times the amount of space in our wingspan, because our wingspan is about 124 feet without winglets. So 124 feet, so we're about 5 times the distance that this has in diameter. Now, obviously, we're not 14.2 foot thick wings, but if you shrink it down to the 3 feet or whatever you got inside there, the 3 or 4 feet you got inside there, and then run it all the way across the 5 times the width of one of these tanks, you're going to be able to fit quite a bit of fuel in there. Now, granted, we wouldn't need a tank this size. Our tank was only 11,000 gallons, like I said before. But still, the fuel is kept in the wings. It's kept in the body. Even though there's moving objects on the backside of the wing, all of this stuff has been built in to the airplane. Okay, it's all been taken into consideration. If you really want to blow your mind, I can show you the freaking schematic out of a KC-135, which is where I started. It's got 10 fuel tanks. It's got, let's see, 1, 2, 3, 4, 5, 6 just in the wings. And then it's got 3 that go down the body, and then 1 that's basically in the tail. It's a ridiculous amount of fuel. It can take about 202,000 pounds of fuel, but it tends to leak now because it's about 70 years old. But, I mean, we would fly all the time with 180,000 pounds of fuel in that airplane. So, you know, let's not get carried away that airplanes can't carry a crap ton of fuel. All right. Now, again, this is what our setup's going to look like. It's very simplistic. The question is how does the fuel get from the tank to the engines? Well, it's a great question. On a 7.5, it's a little weird compared to the 7.6. The 7.6, the pumps are in each individual tank. So the left tank has, you know, your left pumps, and your right tank has your right pumps, and your center has your center pumps, and everything's hunky-dory. On the 7.5, though, it's a little bit different. It's all the pumps may pull from those areas, but they're all in the center tank. So your left tank pumps are actually in the center, your right tank pumps are actually in the center, and your centers are in your center. And then your DC pump to start your APU is also going to be here in the center. Now, why do they do that? I don't have a great book answer where I can point to it and say, here's what it is and here's why. But my guess would be cooling of the pump. So if we think about this, the center tank's got 40 some odd thousand pounds of fuel in it. Most of our flights, you're going to be able to probably just keep it going with just center tank fuel with all you're trying to do. But trying to keep them submerged as long as possible, and maybe that's a reason behind it. I don't really know. I'll be honest. I don't know. If somebody has the answer, somebody works for Boeing or has talked to Boeing or has gotten this answer before and you know it, please let me know in the comments, send me an email, something. Because, boy, I'd really like to be able to point to something that says this is why they do this. Because this is just a weird design to me. It seems like it could almost lead to a single point failure, but, you know, who am I? I don't know nothing. I'm just a guy that likes airplanes. So anyway, that's how you're set up inside your tank. So it's going to look something like this when we talk about how the information gets from the tanks to the actual indicator on the panel. So on the panel, we've got indicators that tell us how much is in each tank, right? And then we get a total quantity. So where does that total quantity come from? If you remember from the 7.6 side, it said that there's a 3-word thing, fuel quantity processor, an FQP. I like those types of responses. So what gives us our total quantity? Fuel quantity processor. How does it do it? It takes all the information from the tanks, the probes, and all that kind of stuff, and then it does a calculation based off of density and altitude and all this other different kind of thing, and it gives you your total quantity. Now, when it does that, it may or may not be correct based on a couple different things. You know, if we have a fuel leak or something like that, it could be erroneous. If you've used APU for fuel or APU fuel to run the APU, okay, that might be a little bit off. But for the most part, it's going to be pretty much dead on for most of the time. It's one of those things that's kind of annoying on the Boeing side where they say works good, lasts a long time. And I mean, that's pretty much what it is. It does. It works good, lasts a long time. Now, differences between the 7.5 and the 7.6. You probably don't notice it here because it's the lines are kind of discombobulated. But if we take a look at this red line, the red line runs from the right tank to the fuel temperature. So on the 7.6, the fuel temperature was taken out of the left wing. On the 7.5, it's taken out of the right wing. So why? Why do we take the fuel temperature out of the right instead of the left? Well, the reason that the temperature is taken out of the left wing on the 7.6 is because there's only one heat exchanger for the hydraulics. You have the left hydraulic heat exchanger in the left fuel tank. Okay, and basically that allows the fuel to cool the hydraulic fluid that's running through there, but it also warms up the fuel. Now the right side on the 7.6, the right side had two hydraulic heat exchangers, the center and the right. So therefore they assumed that the right would be warmer because there was two heat exchangers versus one, so they took it out of what they thought would be the cooler tank. 7.5, just swap your thinking. So the 7.5, it switches. You've got two on the left side, the left and center, and one on the right side, which is your right. So therefore, it's same reasoning. The one heat exchanger in the right wing basically makes them think, okay, the one on the right wing, or the one heat exchanger on the right wing is going to cause the right wing to be cooler, so we're going to take the temperature out on the cooler side. Makes sense. The fuel temperature limitations are generally the same, plus 3 degrees above the freezing point of the fuel being used. You'll have to check your QRH or your FCOM to find a list of fuel that you're allowed to use and their freeze points. And then it's up to 49 degrees C, which is ridiculously hot for fuel. So if you get somewhere where your fuel is 49 degrees C, you probably don't want to be there anyway. Now, fuel config, I forgot to put something, now that I'm looking at it, I forgot to put something in the slides. So, the fuel config light comes on for basically 3 reasons. On the 7.6, it was for low fuel, which was less than 2,200 pounds in either main tank. It was because you had 1,200 pounds or more in the center tank with the pumps off. And then the third reason was 2,000 plus or minus 500 imbalance between the tanks, right? So anywhere between 15 to 2,500 is kind of what your difference there was. On the 7.5, the first two are the same. So the low fuel config is 2,200 pounds in either main tank. The center tank being 1,200 pounds or greater and not having the center tank pumps on, that's another one that'll kick off your fuel config. The third one and the final one, that is the difference between the two airplanes, is on the 7.5, it is an 1,800 pound difference, period. 1,800 pounds, period. So an 1,800 pound difference between the two main tanks, that will cause your fuel config to come off. There's no plus or minus to it. It's just 1,800 pounds. Now, to kind of summarize all of this, you're refueled from the right wing as well. So your refuel panel moved to the right wing. Now your fuel temperature moved to the right wing. And your hydraulic heat exchangers swapped. You got 2 on the left, 1 on the right now. That's why the fuel temperature is taken out of the right wing. The 7.5s don't have jettison capability. Generally, there's not really a need to because you don't carry really high fuel loads. So there's no need for jettison. And then the center tank. So the center tank the center tank on the 7.5 can have up to 2,000 pounds with less than full main tank. That's why I said up to 2,000 pounds with less than full main tanks. As long as your max zero fuel weight, your CG limits and everything else are matched. And the way Boeing writes it, it's kind of confusing when you read it. But basically, if you don't exceed any limits, you can have up to 2,000 pounds in the center tank. Now, the reason I bring that up as a difference, because on the 7.6, you can have how much? Nobody remembers? All right. 22,050 pounds. So 22050. So 22,050 versus 2,000 pounds. And again, a lot of that is just simply because of the sheer size of the center tank on the 7.6. You know, one can hold 80,000 pounds. The other one can hold whatever, 40,000 pounds or whatever we said. So it's not a lot really compared to the other one. Now, if there's any questions, if there's any issues, comments, concerns, difficulties, if you didn't understand something I said, if there's something else that you want me to go over on the fuel system, please let me know in the comments. Send me an email, whatever you got to do. Outside of that, big thing is like, share, subscribe, and share. I don't care where you share. You can share on LinkedIn, you can share on Facebook, on YouTube. Just wherever you can share, please do it. It helps me, helps give me the motivation to keep doing these things and to keep going with what I'm doing. You know, it's I like doing this kind of stuff. I like teaching. So anytime I have a reason to do it, I'm going to do it. So outside of that, fuel is done. We're going to move on to the next one. It's probably going to be, I don't know, we'll find something. But I'll catch you on the next video. See ya.